All right, so let's officially open this open review session. So this is, again, the open review session for the final exam. So let me know anything that you might want to see, any questions that you might have to prepare you for being able to do confidence intervals and Anovas for the final exam.
Can we go over the template that we just spoke to?
Sure. That is a good place to start. All right, so what we're going to do, what we'll start with is the template that I posted. So if you haven't seen it yet in Canvas, in your Excel sheets, I have posted this final exam, whoops. I have posted this final exam template. So this is exactly what your final exam is going to look like. So you are going to have questions, half of it, of the 7-ish questions, are going to be confidence interval questions. So we'll go over how to calculate all these just one more time in just a moment, but just so that you're aware, for the confidence intervals, you will have to, number one, identify the correct t-test to use to generate the confidence intervals. So the first part is going to be, should you use a single sample t-test, a dependent means t-test, or an independent means t-test? And then the second part of it is going to be to generate the confidence intervals. So it's structured exactly like your homework assignment. You need to discover what the point estimate is, the center of your confidence interval, and then the plus or minus lengths of the arms of the confidence interval, and you'll have like 3-ish of those to do. And then the second part of the exam is going to be the Anovas. And for the Anovas, it's a little bit more straightforward in terms of selecting the Anova because we only have the one form of an Anova. We have an independent means Anova. So in this case, what it's going to be, or what the real challenge is going to be, is to, number one, do the correct post-hoc test. So you will be asked to do a specific post-hoc analysis, either a Tukey, honestly significant difference test, or a Bonferroni test, or a SIDAC test. So make sure that you select the correct one from the options in the SPSS test. And then in terms of the information that I'm going to be asking for, the biggest change is that for step 1, I'm just going to provide that for you because the null hypothesis is always that all population means are equal. The research hypothesis is that there's always at least one level that is different. There could be more than one, but there's at least one. So that's just going to be done. The null and the research hypothesis will be provided for you. You will need to indicate what are the degrees of freedom for the comparison distribution. So that is step 2, the between treatments and within treatments degrees of freedom. You'll have to indicate what the alpha level is for the test. So once again, early Christmas gift. You will have to determine the p-value for the Anova. And this one is also more straightforward than previously because there is no one-tailed or two-tailed versions of the Anova. There is just the Anova. So the p-value can be read directly off of the output. And then you either accept or reject the null and the research hypothesis depending upon your probability value and your alpha level. And again, the same logic applies. If your probability is less than your alpha, then you accept the research hypothesis. If it's greater than your alpha, you accept the null hypothesis. But then the other new thing here is that you will also be asked for specific post-hoc comparisons. So you will not be asked necessarily for all the post-hoc comparisons because, for example, here in this one, in a 4 condition, there is, will there be 3, 5, 6? There's 6 post-hoc comparisons. So depending upon the number of conditions, the number of post-hoc comparisons can explode, but you will be asked for specific comparisons. So you'll be asked about, compare the BLA X and the BLA Y patients Do they have a significant difference? Compare the blah W and the blah, X patients. So, and you will have to indicate, yes, there is a significant difference, or no, there isn't, for the specific ones that are asked. So these two questions here are what every single question on your final exam will look like. So if you can master how to do the confidence intervals, which was exactly like the homework, and then if we can, if you know how to do the Anovas, which are much like the previous t-tests with the addition of the post-hoc analyses, then it'll be a very, very straightforward exam. So let's now take a look at how to actually do this. So I'll run through those, and hopefully that will answer many questions that other students might have. All right, so while we're waiting for my SPSS to launch, let's take a look at this first question here. So in the confidence intervals, first thing you want to do is you want to identify which confidence interval you need to do, which t-test you need to do. And again, you do that by taking a look at the descriptions. You do that by asking yourself, how many groups are there, separate groups, or if there's two separate groups, then it's an independent means t-test. If there's one group measured twice, dependent means. If there's only one group compared to a population average, single sample t-test. So identify that off the bat. And then once you've made your decision, you're going to want to format your data correctly. So for this one here, we know it's not a single sample t-test because we have more than just the one sample. So if it was, let's go with the example where group X and group Y are separate subjects. So if that's the case, if we have 9 subjects that were placed in group X and then a separate 9 subjects that were placed in group Y, we're dealing with independent means t-test. So we would format that for our independent means t-test. So that was group X. And we would also do it for group Y. All right, and we have this independent means t-test set up, and we'll just call that scores and the other one group. All right, so we go to analyze, we go to compare means, we go to independent samples t-test. We have the scores as our test variable. We have the group as our grouping variables. We define the groups. Careful to put it exactly as we have in the column. So we got group X and we got group Y. And then we hit continue, and then we go up here to options. And options is where we indicate our confidence interval percentage. Now the first one that we want here is a 95% confidence interval. That is the default. It's right there, so we're good to go. So we hit OK, and we have our output here. So in this case, we have group X here. So if you take a look at the group statistics, I'll just zoom in here. Whoa, that's a lot of zoom. So if you take a look at our group statistics here, we got 9 in each. We got group X with a mean of 78. We got group Y with a mean of 74. If we, once again, just check that real quick in Excel using the average, we got 78 and 74. If we increase the decimals, we can see that, whoops, we see that we have the correct data put in. So we go back here and we need to find our point estimate. So we'll start with that. So if we, I'll zoom in just to get the numbers, but it broke the, let me just show it to you. So in the output here that we have, it has it as a single table. When I zoom in, it breaks it up into 2. But the information that we need is right here at the end of the table. It's in these last three out of 4 columns here. So just again to zoom in so that you can see that a little bit more clearly. We go to these last columns here, and the point estimate that you want is that mean difference. So the mean difference is 3.77778. So we're going to put that in as our point difference, 0.77778. And what we want to do is we do want to check that the sign on this makes sense. All right, so one of the things to do, and I'm not going to play any sort of double negative games with you, but one of the things to do is to make sure that the sign in this point estimate makes sense. So we'll notice that group X is actually higher than group Y. The scores for group X are higher than group Y. Group X has 78 average, group Y has a 74 average. So the scores are higher. So the question here that says how much higher is group X than group Y, 3.7 seems correct, right? It makes sense. 3.7 is saying that group X is 3.7 more than group Y, and that's exactly the case.
You're saying the averages are?
Yes. Yep.
Okay.
So that makes sense in terms of our point estimate. And once you have your point estimate, you can just pop that into the rest of these portions of your confidence interval, because your confidence interval is always built around your point estimate. It's always centered on your point estimate. Your point estimate is your best guess. The confidence interval is built around that best guess. So you can immediately just pop those in for that aspect of the confidence interval. Now we need to know what the arm length is down here. Yep. All right. So now we have to get the arms of our confidence intervals. So this can be done a number of different ways, but the way that I typically like to do it is I will take, and we have our, I'm going to zoom out just a bit. Go back here just real quick. So one of the things that I like to do is just have a system that'll always work. And one system that'll always work is you take your upper minus your middle, upper minus your point estimate, in other words. So if we see our upper here, it's 14.02669. So that number right there, this 95% confidence interval of the difference, 14.02669. So we can pop that in here, equals 14.02669 minus, and then we've already entered in our point estimate. We've already entered in our center estimate. So we can just minus that point estimate right there, and we have our plus or minus value for our 95% confidence interval. So that gives us the 95% confidence interval. And then if we want to do the 99, we go back, analyze, compare means, independent samples t-test. Everything is already set up, so we can just hit options, and then we go into this confidence interval percentage and we change that to 99%. We hit continue, we hit OK. We have our new 99% confidence interval of the difference. And that's another sort of tip that I will mention to you. Always check to make sure that you're looking at the right confidence interval, because if you're computing more than one, depending upon how your computer updates its output, you might pop up back here at the 95%. So SPSS is very friendly. It's letting you know, yep, you put in 99%. So once again, we got upper here, 17.89862. So we can go back here, equals 17.89862. And then once again, upper minus middle will always work. So we go upper minus our point estimate, and we find a plus or minus of 14.12. So that is the way that you would calculate this for an independent means t-test, and then this is the format that you're looking for. So once again, once you find your point estimate, that's going to be the center for all your confidence intervals, and then you just calculate your confidence intervals using the appropriate t-test, using upper minus middle, and then one last little check that you can give just to give you, again, extra confidence that you've calculated things correctly, that nothing has gone really wrong. The bigger your confidence level, the higher your confidence level, the bigger your interval should be. So when I take a look at this, I see that my interval for 95% confidence is plus or minus 10. For 99% confidence, it's plus or minus 14. That makes sense. 99% confidence is a bigger interval than 95, so that's an indication that that was done correctly. So that's for an independent means t-test. So while we're on this subject, let's do this if we decided that it was a dependent means t-test. So for a dependent means t-test, we would basically set it up for a dependent means t-test where we have in the first, where we have group X in the first row and group Y in the second row. So if we read this description and it said that subjects were placed into the X condition and they were measured once in the X condition, and then the same 9 subjects were placed into the Y condition and they were measured in the Y condition, if it was like a pre versus post type of experiment, then this would be a dependent means t-test where the same subjects were measured twice. If the same subjects are measured twice, then we have the group X scores in one column and we have the group Y scores in a second column, so that every single subject has 2 scores in their row. And again, remember that defining principle, every row of SPSS is one and only one subject. So once we have it in this format here, we can go to analyze, we can go to compare means, we can go to a paired samples t-test. So the paired samples t-test is the dependent means t-test. And then in this case, this is a perfect example again of just making sure that you don't need to do massive mental gymnastics. So I'm going to pop group X in and I'm going to pop group Y in because we're going to compare group X to group Y. And then in the options here, I'm going to make sure that my confidence interval percentage is the first one that we want. We want a 95% confidence interval. So it's already set up for 95%. We hit continue, we hit OK. And then notice down here in the mean value, there's a mean value of 3.77, but it's positive 3.77. And we've already determined that X is higher than Y. So the estimate of how much higher is group X and group Y is going to be a positive value. So if this came out negative here, where it was indicating that the decrease in group Y was a negative decrease, well, that's too much mental gymnastics for me to do if we're trying to estimate how much higher group X is. So I would just go back to the data editor. I would go back to analyze, compare means, paired samples t-test. I would highlight one of the variables, and I would use this arrow here to switch them around. As it is, I had a 50-50 shot of getting it right the first time, and luck was on my side. So we can go ahead with calculating this 95% confidence interval. First thing to notice is that the mean difference here is still the same. So that's a nice little safeguard in the sense that even if you get the test wrong, you'll still get the point estimate right. So the point estimate will not change depending upon is it a dependent means or an independent means t-test. So at the very least, you should be able to get the center of your confidence intervals. So it's still 3.77778, right? That's still the mean difference right down there. That's where you find it on the dependent means t-test. And then once again, SPSS being very friendly, showing you right there, 95% confidence interval of the difference. And once again, we can just go upper minus middle. So upper is 11.50067. So we can just pop in here and change that 14 to 11 point something, 11.50067. We hit enter and we have that confidence interval correctly calculated. And then once again, it's set up correctly, so we can just go back, analyze, compare means, paired samples t-test. It's already set up the way that we like it. We go to options. We change this now to 99 because the next part of our question was asking for a 99% confidence interval. So we have our output. Once again, notice the center has not moved. So that point estimate, that center of your confidence interval has not moved. But now the upper value is 15.01509. So we go in here and we pop that in 15.01509 and 15.01509. There we go. And we got that interval correctly estimated. Once again, we just do that final double check. We got a 95% confidence interval. It's plus or minus 7.7. We got a 99% confidence interval, plus or minus 11. The interval for 99% is larger than the interval for 95%. Higher percentage requires higher intervals, so we have more confidence that we got that done correctly. All right, so that's the confidence intervals. So what we're going to do right now is we're going to go through the Anova. So for the Anova, you almost, you can do this entire Anova without ever reading the description of the Anova. So I highly recommend not doing that because it just doesn't let your human mind sort of cognitively understand the situation, right? A situation is always easier when there's a little bit of context there to understand it. But let's just say that time is running out on the exam and you got one question left and it's an Anova. Just know that every Anova we're doing is the same. It's all a independent means, a single factor Anova. They're all set up exactly the same. So you can literally run the correct test using this blah, blah, blah information. That's enough information to run the correct test because we're doing an independent means single factor Anova. So the key here is setting it up correctly. And an Anova is basically set up exactly the same way as the corresponding t-test would have been set up. So the way that we would have set up an independent means t-test is analogous to the way that we're going to set up an independent means Anova. So what we're going to do is we're going to take blah W here and we're going to copy those scores and we're going to put it into the first column here and we're going to label that scores. And then right next to it, we're going to put blah W. And we're going to copy that and we're going to paste it all the way down. And remember that that is just to jog our memory. So let's just call that name or names. And that's just the names of the groups. So we got blah W is going to be one of the names of the groups. And let's get all the groups in there. So we got blah X. And we put that directly underneath, once again, much like an independent means t-test. And this is blah X. And then we got to pop in blah Y. And one more blah Z. All right, so we have it set up here. We got it set up correctly for a, if we were doing an independent means t-test, this would be the way that we set it up. However, you'll notice that if we go to analyze, if we go to compare means, and if we go to one-way Anova, so that's where you want to do, that's what you want to choose. That's where you'll find your one-way single factor Anova, your independent means single factor Anova. If we click here on one way, you'll notice that we have the scores, we have the raw scores for the dependent list, but we don't have any variable here for our factor. We don't have any variable here for our independent variable for our groups. Now we did it the way that we normally did it for an independent means t-test, But for some reason, I have no idea why, but for some reason it just doesn't work for an ANOVA. There's nothing here that says, hey, define the names of your groups. So we need to go back and we basically need to label these with numbers. So group W, blah W, we're going to label with 1. And then blah X we're going to label with 2. And blah Y we're going to label with 3. And blah Z we're going to label with 4. And I intentionally made an error there just to show you one of the things you want to do. So we go back to variables and we're going to call this one groups. And we go back to data view. And now when we go to analyze, now when we go to compare means, now when we go to one-way ANOVA, we have our scores waiting for us there, and we put the scores into the dependent list. That's where your raw scores go. And now we have the groups. Now we can tell SPSS, yeah, we got 4 different groups, and they are labeled 1, 2, 3, and 4. So that's what we got. We're going to want to go to options and choose descriptives. Descriptives is going to generate that top table that is going to give us the means for each group. It's going to give us the number of subjects in each group. So we want that. Don't click on the rest because we don't need that information. And then we're also going to go to post-hoc. And if we were asked for a Bonferroni test, we would click Bonferroni. If we're asked for a SIDAC, we'd click on SIDAC. But we were asked for a Tukey, honestly significant difference. So we are going to click on Tukey. That's the one for Tukey, honestly significant difference is just Tukey. And then the last thing we want to do is whatever our alpha level is, change this significance level to that alpha level, and it will be a double check when you're doing your post-hoc analyses. So when we have all that set up correctly, we hit continue, we hit OK, and then we have our ANOVA output. Now I mentioned that I made an error intentionally when I was entering in the data, and this is why we run the descriptives table here. So when we take a look at these descriptives, we'll notice that SPSS says, oh yeah, you have 8 subjects in condition 1, in group 1. And we say to ourselves, yeah, that's exactly how many we're supposed to have. And it tells us you have 8 subjects in condition 2, which is exactly how many we're supposed to have. But then all of a sudden it says, hey, we got 9 subjects in group 3. That's not right. We're supposed to have 8. And we got 7 subjects in group 4. That's not right either. We're supposed to have 8. So this immediately tells us that something went wrong. And it is incredibly easy when you are just clicking through 1s and clicking through 2s to go one number too many or one number too few. And what happened in this case is when I was blazing through this, you'll notice here on this entry here, I put that blah Z score into the blah Y group. I labeled it incorrectly as a number 3 instead of a number 4. So I can easily correct that, but that's why you want to check your descriptives. It is super easy to just go one number too many or one number too few. So you definitely want to run those descriptives. If you find a mistake, just go back, rerun the test. We have it all set up. SPSS will remember everything that we did, so we can just hit OK. And now we have 8 scores in group 1, 8 scores in group 2, 8 scores in group 3, and 8 in group 4. Once again, lets us know that we didn't make any errors. We could calculate the means and double check them against these means here, but I think that's enough of a double check for the time being. All right, so what we need to do first is we need to go to our Anova here. So I think I can zoom in on that one. Yeah, sweet. So we'll go down to our Anova, which has been placed all on one. Nice. So this is the Anova table here. This is where we want to find all our information. So once again, we have our null hypothesis and our research hypothesis. That will be provided because the null hypothesis is always that all the populations are equal. The research hypothesis is that at least one of them is different. Then we want the degrees of freedom between treatments. So make sure you pay attention to that subscript. So we go back to our output here and we go to between groups. So So your textbook calls it between treatments, SPSS calls it between groups. The only important thing is that it's between. We find the degrees of freedom, we got 3 degrees of freedom. So we go back here and we pop in 3 degrees of freedom. For the within treatments, same thing, we go here within groups, 28 degrees of freedom. So we pop that in, that is the comparison distribution done. Alpha level comes from our question, that is 0.05. So the last thing we need is we need that p-value. So that p-value is this significance right here. So we just read it directly, we don't have to do anything like in a t-test. So we got 0.006. So we go back, we pop that in, 0.006. And then we have to make our decision, and because our p-value is less than our alpha value, we are going to reject the null hypothesis, and we are going to accept the research hypothesis. And as it turns out, there is a difference somewhere in the blah W, blah X, blah Y, and blah Z populations. So what we have found is that they are not all the same. At least one of them is different. All of them could be different. One of them could be different, 2 of them could be different, and that's where we do these post hoc analyses. So in the post hoc analyses, these are where we go to our post hoc, no, it's page 1, let's close this. This is where we go to our post hoc table, which is this one right here. So it'll say post hoc tests, and it'll say which test you did. So it mentions it was the Tukey honestly significant difference test. So we can zoom on to that output. So that's up there at the top right there. So let's get in there so that we can see it. So what we need to do is we need to identify which of these groups or where each of these comparisons are on this table. So one thing that you can do is you can, to sort of help you out on this, is you're going to want to have this written down somewhere. What numbers are blah W, what number is blah X, what number is blah Y, what number is blah Z. So if we go back here, we see that blah W is 1, blah X is 2, blah Y is 3, and blah Z is 4. So you might want to just do that right at the beginning and say, all right, this is blah W versus blah X. So that's going to be 1 versus 2. Let's get that a little bit closer. And this is blah W versus blah Y. So that's going to be 1 versus 3. And then it's blah X versus blah Y. X is 2, Y is 3. So that's going to be 2 versus 3. And then we got blah Y versus blah Z. Y is 3, Z is 4. So that's going to be 3 versus 4. So just anything to offload that cognitive load from your mind onto an external device is fine. And you can, anything within the confines of the black box on your Excel, you can write in that so long as your answers appear in the answer cell. None of the formulas will be messed up anywhere else. So in this case now, it makes it a little bit easier cognitively. We're looking for 1 versus 2, group 1 versus group 2. We go back to our output, and lo and behold, we have group 1 versus group 2 right here at the top. We scroll across to where the significance level is. That significance level is higher than alpha. So much like a t-test, we take a look at our p-value. Our p-value, the significance level, is greater than our alpha level. So we accept the null hypothesis. We say that there is no difference. And then also notice in this mean difference, there is no asterisk. And the lack of an asterisk means that the mean difference is not significant at the 0.05 level. So for this one, is there a significant difference between blah W and blah X patients? We would conclude no. So the next one, blah W versus blah Y, 1 versus 3. Once again, back to the table. We have to find group 1 versus group 3. So remember that in this first column here, the 1 continues all the way down until the line. The 2 continues all the way down to the line. So this is 1 versus 3. We scroll across here. We see that the p-value, the significance level, is 0.003. That is less than alpha level of 0.05. So we reject the null hypothesis. We accept the research hypothesis. We say that there is a difference. And lo and behold, SPSS has also put an asterisk on that mean difference. indicating that yes, what we just concluded is correct. The mean difference is significant at the 0.05 level. So we go back to our answer cells and we put in yes. Blah X versus blah Y, also known as 2 versus 3. We go back to our output. There is group 2, there's group 3, so this is the column we want. And once again, we go over to the significance level. We find a p-value of 0.241 that is larger than 0.05, so we accept the null hypothesis. No asterisk there, no mean difference, or sorry, no significant difference. So we go here and we put in no. And then finally, blah Y versus blah Z, also known as 3 versus 4. We go back here, there is group 3, all the way down here, 3 versus 4. We scroll across and we find 0.581. That is larger than 0.05. So we accept the null hypothesis. There is no difference. And once again, no asterisk there, indicating that SPSS agrees with us that there is no difference. So we put in no. And if you inspect the entire table, you'll notice that the only difference here is blah W versus blah Y. That is the only significant difference in this entire table is group 1 versus 3. Group 1 versus 4 comes close, but it doesn't cross that line. It's only that one group that is different from that one other group. And that is the one-way ANOVA. So those are the two types of questions that you will encounter on this final exam. So if you can successfully navigate those two types of questions, you should be able to get 100% on this upcoming exam.
So you compare, when you go back to the table?
Yep.
Compare the significant difference to the alpha level?
Yes.
Okay.
So the alpha level that is given to you for the ANOVA, that's the alpha level that you use for all your comparisons.
Okay.
So this significance level here,
Right.
it's almost like just doing a t-test. So that's your p-value, and if it's greater than alpha, it's the same decision. Greater than alpha means you accept the null hypothesis, less than alpha means you reject the null hypothesis. So that still works exactly the same way.
Okay. Yeah, because it just says like yes or no, so I wasn't sure if it was just saying
Yes, so
to,
rejecting the null hypothesis means that there is a significant difference. So that's what that means. So if you want to make a note of that, if if alpha is greater than your significance, then no significant difference. If sorry, I want to make sure I got that right. If your p-value is less than alpha, then there is a significant difference. Then yes, significant difference. If your p-value is greater than alpha, then no significant difference. And you can hopefully see in the bit of difficulty I just had right there that it might be a good idea to have that written down somewhere to refer to during the exam. And you had another question? Did you have another question? No? Okay. Yep.
So on the exam, is it just going to ask the yes or no, or are you also going to ask to accept or reject it?
Just yes or no.
Oh, okay.
Because yes means that you accept the research hypothesis. No means that you reject the research hypothesis. So yes means that there is a difference. No means that there is no difference. So it's it's the analogous sort of decision. Mm-hmm.
Would that be the same thing if we were asked to do a different post-hoc test? Like we would still be looking at the significance?
Yes. So the in terms of the post-hoc test, I'll show you one of the other ones. So if we go to analyze, compare means, one-way ANOVA, and let's say we go to post-hoc, and one of the ones I use most often is SIDAC, and you hit continue, and you hit OK, you'll notice that the output looks exactly the same. It works exactly the same. If you compare the two of them, you'll notice that the numbers are slightly different, not very different, but slightly different, because there's pros and cons to the different types of post-hoc tests. But it's still the same table, it's still portrayed in the same way, the significance level is still used in the same way. And very nicely, SPSS just reminds you, in case you forgot, this is your SIDAC post-hoc analysis. So do make sure that you do choose the correct one. Chances are it's not going to make a huge difference. They usually don't. It's a little bit of splitting hairs, but as you're going to learn if you go into grad school and you take another statistics course, and as has been a theme in this entire course, you want to analyze your data as accurately as possible just because of the high stakes of the kind of work that we do in psychology. So choosing the right sort of post hoc analysis, making sure that you're not inflating that alpha level is something that you'll learn more about in your career as a psychologist. But for right now, just knowing how to navigate a post hoc analysis is what we want to do for this intro to statistics course. But yeah, it's set up exactly the same. And even the asterisks are there. Now, on that note, for the asterisks, if you are going to rely on the asterisks, make sure that when you do your test, you set your alpha level in your post hoc analyses. So our alpha level was 0.05, and you'll see that the asterisk here is the mean difference is significant at the 0.05 level. So you want to compare it to 0.05, and SPSS is comparing it to 0.05. However, if you wanted to do it at 0.01, so if the test said use an alpha level of 0.01, when you go into post hoc, you need to change that to the correct alpha level. So if we're doing a 0.01 alpha level, that needs to be changed. And when you hit OK and it runs its analysis, notice that now the asterisks are for the mean difference is significant at the 0.01 level, not 0.05. So again, SPSS will do what you ask. Make sure that you are asking for the right thing, and make sure that you're using that asterisk as a double check. You need to set up that alpha level correctly in that post hoc analysis. So there was a question about calculating effect sizes. And effect sizes, there is a formula in your textbook about variance between multiplied by degrees of freedom divided by variance between multiplied by degrees of freedom between plus variance within multiplied by degrees of freedom within. So that is a rather involved formula. So one thing that you can do, if you do have the raw scores and you can run the Anova and SPSS, in the table right there, you'll realize that you have your sum of squares. So that is the sum of square deviations that we were using previously. If you can remember back to when we were initially introducing variance, you had your sum of squares right there. And then the formula for variance was sum of squares divided by the degrees of freedom. So you got sum of squares right there. You got degrees of freedom right there. So you have SPSS helping you a little bit along the way to get to that calculation of effect size. Because if you have sum of squares divided by degrees of freedom, that will give you that variance, and then you can use that to calculate your effect size using the formula provided in the textbook. So it would be nice if it did calculate it, and I know there is a way. I would have to check a YouTube tutorial to remember exactly how to do this, but I know there is a way to ask for effect size calculations. But again, that would be your best bet in terms of how to do that for your homework for the post-hoc test as well. Mm-hmm.
But we won't have to calculate effect size for the check?
No. So once, just to be absolutely sure and clear on this, what we just did in the exam template, that is everything you're going to be asked for on this exam. So you're going to be asked to calculate confidence intervals. They will look exactly like that. I will ask for exactly that information, point estimates, and then 2 confidence intervals. The confidence intervals could be different sizes. They're not all going to be 95 and 99, so make sure that you pay attention to what the interval is that is being asked for. And then for the ANOVAs, it will all be the ANOVA that we learned, that independent means single factor ANOVA, and you'll be asked for the exact same information, the degrees of freedom between, degrees of freedom within, the alpha level, the p-value, accept or reject the null hypothesis, and then you'll be asked for selected comparisons. So make sure that you can identify which of the comparisons are being asked for, read them off the table. Yes, there is a significant difference. No, there is no significant difference. Also known as yes, we did accept the research hypothesis, or no, we rejected the research hypothesis.
So we have like 7 questions, or?
Yeah, I'm finalizing it, but we definitely have 7. Whether or not I go to 8 or not, I'm still trying to see what I might do, but we'll definitely have 7. And it'll be pretty much split right down the middle, where half of it is confidence intervals, and the other half of it is ANOVAs. And much like the previous exams, if you knew exactly what you were doing and you were well experienced in statistics, you could complete this exam if you were doing a speed run in probably around 20 minutes, right? If I was doing this exam without taking the time to explain, I could probably blow through it in about 20 minutes. So what that means is that we are going to do, I believe I scheduled it for 90 minutes, so you do have a little bit of extra time. But what that really means is that you only have about 20 minutes of actual typing and formatting of data to do, which means that you got 70 minutes to sit there and just make sure that you're doing things correctly. So make sure that you use your time wisely. Make sure that you're taking the time to identify the correct t-test to do so that you can calculate your confidence interval. Make sure that you are taking the time to just real quickly glance at those descriptives so that your finger didn't slip and something didn't go wrong. And make sure that you're taking the time to identify the correct post-hoc rows for your post-hoc tests, because again, it's easy under that kind of high pressure situation to make those little errors. So take advantage of the fact that there's only really 20 minutes of actual kind of work to do in the exam, which leaves you 70 minutes as introductory students to kind of say, all right, what is it that I need to do now to think about it? So again, just use your time wisely in that regard. Make sure you're using SPSS. Otherwise, you will have no chance to complete this exam in the time that it is required. So make sure that, I know most of you have been using SPSS, and that's been pretty clear, so keep doing that. And if anything, just to kind of remind you of some of the policies. You can bring any materials that you want. So no cell phones are allowed, because we're not allowed, you can't communicate with other individuals. But any notes you want to bring, you can sign into Canvas, you can sign into the MyLab, so you can look at your textbook. You actually won't need your textbook. There is no consulting of tables in this exam, but you will have access to your textbook if you want to use that. Any notes that you make, anything that you want to bring in, absolutely acceptable. And then if anything goes weird in Excel, feel free to call me over. If it's something that I can fix, if it's outside of the scope of the course, I would be more than happy to, do that for you. If it's part of the question, I will just let you know that is part of the question. And then also, make sure that if things go wrong in SPSS, that is an indication that you have usually formatted your data somehow incorrectly. So if you run your SPSS test, usually the typical thing that occurs is SPSS tells you, I cannot generate an output. That is your clue that you have incorrectly entered your data. So take that for the information that it gives you. Go back to your data, make sure that it's formatted correctly, make sure that if you're doing an independent means t-test, for example, that you have named your groups in the independent t-test the same as you named your groups in the actual data entry. And again, SPSS is one of the reasons we use it in this course is it's much more user-friendly than a lot of other statistical packages out there. And when you make an error, it will let you know. It'll put up those little warning error messages, and use them for read them and say and identify the issue that SPSS is indicating. All right, so we still got about 25 minutes. So, yep.